couldn't get the link to work for the water.
Yeah.
What browser were you using? Internet Explorer.
Yeah.
Okay, so it could be. Sometimes certain apps don't work well in some browsers, so just try a different browser.
Wait, here's something, but it wasn't the right thing.
Yeah, so here's what you should have saw. So if I put a link in the lesson 1.4 page, so right here, National Geographic Water Footprint Calculator. And then, so I wanted to just read through this article. They just talk about, water stuff. Like, it's amazing. How many people let the water run sometimes when they're brushing their teeth? Right, we all do that sometimes. If you measure how much water that is, you lose like gallons if you just don't think about it. So little things like that make a big deal. Anyway, so they just talk about how we use water, how it relates to diet, how it's related to driving around, power, and then right here is the link to the actual thing. And so it must remember that I did it before, so I'm going to restart it.
Yeah, it kept taking me back to the same.
Yeah, so it should take you to this right here. So it could be a browser thing. So just try a different browser. So give it a shot later today. And then it'll ask you how many people are in your household. And eventually at the end, it'll give you a graph. And I'll show a couple of examples of that shortly. Yeah, so please do that. If you didn't do that yet, I need this ASAP. So get that in. So we have 3 submitted so far.
We're supposed to submit it to that.
Yeah, just in the student view, there's the submit button here. So just submit your screenshot right up there. Yeah. Okay, so, it looks like I did put a couple in here. Let's see. Yeah, first you get, oh, that's the second view. If you scroll at the end, if you scroll down a little bit, they show you a chart about where your biggest water usage. And it turns out if you have a yard, indoor water is like the smaller part, outdoor, and then virtual water, that's like water related to the food you eat and the driving you do, things like that. Turns out to be like the biggest use of our water. So I recommend when you get the first page, which looks like, it's a screenshot. Come on, bring my screen back. There you go. Maybe it's this one. Yeah, the first screen you get looks like this. If you scroll down the page, it shows you that graph. So definitely take a look at that graph. And in that graph, when you point to different columns, it'll tell you what that column means and how many gallons you use in that particular category. So take a look. Good quantitative information. Okay, leave student view. And let's see, that for now, that for now. That can go, that can go, that can go. All right, hey Jose. And back here. Okay, so from lesson 1.3, a couple of review things. Most common problems people had were misreading things. So like one of the problems near the end said to take 6.3 times 10 to the 12th and divide it by 7.8 times 10 to the 15th. And half of the class multiplied instead for some reason. I don't know why. So if there was multiplication, you absolutely would have got it right, but for some reason, most people didn't. Missed that divide and multiplied instead. Yeah, it could be the parentheses throw you, and there were a bunch of multiplications before that, and no big one, but just be careful on that. The other thing is a lot of people wrote down good stuff, but then they had like little errors, and if you had just plugged it into a calculator, it would have checked. So I'm going to do this one by hand and then plug it into a calculator just for review. So I'm going to rewrite it as a fraction, 6.3 times 10 to the 12th over 7.8 times 10 to the 15th. And the way I attacked these in class the other day is I dealt with the regular numbers separately and I dealt with the powers separately. So on a calculator, I want to figure out what is 6.3 divided by 7.8. So everybody whip out a calculator. So 6.3 divided by 7.8, type those right. So my calculator says it's 0.807 blah, blah, blah. I'm going to grab, say, the first 7 digits, or sorry, first 4 digits. I would round that 6 to a 7. So 0.8077, I'll call it for now. So I get about 0.8077. And then we have a rule about powers of 10 when you divide them. You write the base, then you do what with the powers? You subtract them. Now, a lot of us skip writing this down and just do it in our head. If this is on a test or this is for some important thing that you're doing, write it down so it doesn't get messed up, because it's easy to make a subtle error. 12 minus 15 leaves us what? -3. And some days I rush through these kinds of things and I'll just throw a 3 down when it really should be a -3. So it's kind of worth writing this step down sometimes. So I get times 10 to the -3. Is this in scientific notation? No. So we got a couple of options, easiest of which I think is just to apply the 10 to the -3rd. What's that going to do to the decimal point? Move it left or right? Left. It's going to make it smaller because it's a negative exponent. Negative exponents means you're dividing by 10, so it's got to go that way. How many places? 3. So I'm going to have a 1, 2, 3, and then the 8077. Decimal point goes right there. To be in scientific notation, I want the decimal point to be right there, so I just count 1, 2, 3, 4. So the correct answer in scientific notation should be about 8.07, 8.08, something like that, times 10 to the -4th, because it's a small number. All right. Now, could I have screwed that up? Totally. So then I whip out my calculator and I just type all of this into my calculator. So I'm going to go to Google as the calculator and clear this. And I'm going to use parentheses just like it came. And so on paper it said parentheses 6.3 times 10 to the power 12. Close parentheses, divide parentheses 7.8 times 10 to the 15th. And I think that looks right. Equals, yeah, that looks like about the same number, right? 1, 2, 3, 4 decimal places over. So it checks out. So I highly recommend on these problems, try to do it by hand, writing stuff down, and then plug it in the calculator and see what happens. And most modern calculators, you can just type exactly what you see and it'll spit out the answer. What's the exception for calculators that don't do exactly what you see? Yeah, the standard iPhone calculator, iPad calculator doesn't do it this way. It's more of an old-fashioned calculator, which is kind of weird because Apple's on the cutting edge of everything. I should write to them. I'm sure they'll listen to me. Okay, let's see. Other thing I wanted to note. When you're asked something on the lessons, like let's take a look at the lesson 1.4 worksheet. If it asks a question, write your answer as a sentence whenever it's information that's applied. You know, for something like the problem we just did, where'd it go? There's no point in writing a sentence for that answer right there, right? It doesn't talk about population, it doesn't talk about water usage, it's just, hey, do this calculation. But anytime it's in a sentence in context, write a sentence back. And on some lessons, people just wrote 22 or 2.5 instead of 2.5% is how much bigger China is than the US or whatever. So write sentences wherever possible. So those are my biggest tips about that kind of stuff. What do you got? 1.3 for me? All right, let's see. Kyle, we missed you yesterday. Here is a worksheet, and National, did you miss you yesterday too? Worksheet for today. Everybody else has the 1.4 worksheet, right? All right, so let's see. Let's take a look at a couple things. We started looking at that table in class on page 4-ish. Is that where it was?
3.
Page 3. All right, so we started this page right here about the US versus the world. Then the next page is China versus the world and China versus the US. I asked you to look at that on your own. You can group up in just a minute and compare each other's sentences and calculations on that. And then this table right here, we had just started. And I was writing it up on the board, I think. I typed some of this information into a spreadsheet, so I'm going to start looking at that spreadsheet right now. Let's adjust this, make sure it presents right. Okay. So let's see, that's right here. So did I type this right? We've got China, India, US, correct? Okay, and then millions of people is the next column. And I've got 1346, 1241, 312, and then water in billions of cubic meters per year. Does that sound right? A couple nods, okay. And then we're going to do a division on those to calculate cubic meters per year per person. And then we're going to compare that to what the water calculator said. That's a little more than what this project asked for. And then I'm going to shut up for a while and let you guys group up and go over these answers together and start writing some sentences. So I'm going to delete those numbers in that one and recalculate. So what's the problem with the way I have these written right now in terms of doing calculations? Yeah, they're not in scientific notation or even standard notation, because up above it says, oh, by the way, that's millions, not thousands, right? So I really should rewrite those. So I'm going to just copy this and write it underneath. And I'm just going to call this people, P-O-P-L-E, there we go. Let's see, if that's millions, how many zeros do I need to put on there? 6 more? Yeah, so 1, 2, 3, 4, 5, 6. Got it. This one I got to do the same thing too. 1, 2, 3, 4, 5, 6. So if you didn't already write this on your chart, on your paper, do it now. Okay.
China was already done.
We started it. I don't remember how far we got. Oh, they did China for us. Yeah, yeah. So start writing in the other ones. Okay, let's see. This one is billion. So how many zeros do I need? 9? Yeah. So 9. Right. It'd be nice if I had commas in there. Add them. So highlights, number format, number. It gives me decimals too, so I can just drop the 2 decimals it gives me, and then widen the column so I can read the number. Okay. Ones, thousands, millions, billions. And let's blow this up for Daisy and Jose out there. Okay. So this is what you should have written on your paper as of yesterday. We want to calculate, so this is how much the whole country or the whole region uses in cubic meters. A cubic meter is a pretty big thing, right? Everyone know how big a meter is? I think we talked about this the other day. A meter is up to my waist, pretty close in flat shoes. So it's roughly a little over a 3 feet by 3 feet by 3 feet tank of water. Okay? And we're using billions of those. I can't even. Is that like what? A Great Lake, maybe? I wonder what that is. Volume. Do they give volume? Somebody's probably calculated that stuff. Volume of, let's see. Ooh, how about the Great Salt Lake? Down there. Great Salt Lake. They give it in acres. That's not volume.
So like find on the one like question.
Yeah, yeah. Sometimes the number you want is not there. You got to convert. So okay. Anyway, I'll look that up later and come back to you. So I think I just need to divide water per person. So what is going to be in the denominator of the division? The people or the water? What order do I divide this in? Water divided by people, right? Yeah. Water per person. So I'll calculate these numbers and you guys can just write them down. All right, so those are the numbers I get. Oops.
Can you tell?
Sure. And I have 2 decimal places. Do I really need them? I don't know. I could probably round to the nearest whole number, and that would probably be all right. I probably must have earlier hit that number format, which automatically gives you commas in 2 decimal places. Okay, so those are the numbers there. For those of you who did the water calculator, what numbers did it tell us about? So mine was in the like 2,000 range, but 2,000 what? Anybody remember the units? Gallons, okay. Per day, yeah, it was gallons per day. This is cubic meters per year. So let's see if we can change these numbers into what the National Geographic water calculator is telling us. Because they're not directly comparable, right? Cubic meter is totally different than a gallon. How many gallons do you think are in a cubic meter? Picture a gallon of milk, picture a 3 by 3 by 3 tank. So there's going to be a whole bunch of gallons in there. Somebody take a wild guess. How many gallons would be in a 3 by 3 by 3 tank? 40? So just a note, in a 1 by 1 by 1 tank, 1 foot by 1 foot by 1 foot, there's about 7.5 gallons. 1 by 1 by 1, 7.5. All right, let's look it up. So we in a cubic meter, and 264-ish. That's a lot of gallons. I was always amazed at the 7.5 gallons in a cubic foot. A cubic foot doesn't seem like it's all that big, but it's big enough. Okay, so in every cubic meter, there's roughly 264 gallons. Okay, so if we had 1,000 cubic meters, right, we would have 1,000 times this, agreed? So I think we need to multiply this number by these numbers to turn this into gallons. Okay, does that sound right? Here's what I do when I'm not sure. Pen. So we were just told that 1 cubic meter, I'm going to write it as CUM, is about equal to, what was it, 264 gallons roughly? Gallons. And I have a number, let's say I have 1,000 cubic meters. So what I do is I create a fraction where I want to cancel, I view this as over 1, I want cubic meters to go away, so to cancel it has to go on the bottom, which means gallons has to go on the top. That means the 264 goes in the top, which means I'm multiplying by it. If it ended up in the bottom, what would I do with it instead? I would divide by it, yeah. So every once in a while I have a brain freeze and I'm not sure whether I should multiply or divide, so I set up fractions like this to help me figure it out. All right, so back to the spreadsheet here. So we're gonna do what? We're gonna do gallons per year per person, right? Because the only thing we're changing is cubic meters to gallons. Everything else stays the same. What's that? You don't have to write this down.
Okay.
I just, see, my problem is when the first time I did this, I said, okay, I can see how much people use. And then I did the National Geographic one and I'm like, wait, these don't match. And then I realized, oh, they're totally different units. Cubic meters per year versus gallons per day. So we're just gonna do the conversion to see how it compares. Okay, so let me word wrap this so it's prettier. So this is just a little something extra. So what I want to do is take the numbers I was given, multiply them by 264, and that tells me how many gallons per year. Oops, format, number, let's decrease decimal. Okay, so I'm just going to go to the nearest whole number. So in which row are we? Last one, US. So in the US, this says the average person uses almost 700,000 gallons of water a year. It's a lot of gallons. All right, so next we're going to change that to per day. So gallons, I think it's typing above. Gallons per day per person. Pretty It's weird having this giant font. Crap. Okay. So how do we change years to days? Almost 365.
365.
Yeah. So we are looking for groups of 365. So we're going to multiply or divide by 365 here. Divide, yeah, because we're looking for groups of 365. So I type equals, I click on my number, and I encourage you to play around making a spreadsheet like this. It's good practice. When you go to get a job, if you say, hey, I took quantitative literacy, people are going to look at you funny. But if you say you know how to use a spreadsheet well, that's a good in. So please practice your spreadsheets. Let's drop some decimals. You don't like spreadsheets?
I didn't, not until I did computer science.
They're awesome. I use them all the time. Okay, so almost 2,000 gallons of water per day. How many of you did the water calculator? Is that about what you guys came up with? Close to 2,000-ish a day? What'd you get? Do you remember? 1534. Okay, so you're on the low end of usage. Some people are higher up. It just kind of depends. What did I come out to be? I came out to be 1,194. Here it says the average U.S. person uses about 2,220. Okay. It doesn't say what year that measurement is in. What year are these numbers from? What's this? 2011. Okay. Yeah, so that was 6 years ago. Yeah. So are we in the ballpark? Yeah, in the ballpark, which is what we're looking for. Okay. I'm about ready to set you free to do this without me. And I'm just going to walk around and offer suggestions. So let's see. Let's do one more thing. Let's compare China to the US in water usage. China compared to the US. So look at the numbers on your sheet. You're going to do a calculation that compares China's water usage, let's see, per person, use the third column number, to the US water usage per person. Okay, so do a calculation, and then we're going to try and write a sentence based on a calculation. So there's lots of different calculations you can do. Just try something. Don't worry about being wrong. There's multiple right answers here. Let's see, third column here. So we want to compare that number right there to that number right there. So that's the cubic meters per person per year is what those numbers are. Let's highlight those suckers. Scroll so we can read them better. So do some kind of calculation with those two numbers so that we can make a comparison between per person water usage in China and per person water usage in the US. And then make a stab at a sentence with those three numbers you calculate. So I'm not exactly addressing a direct question on that worksheet yet. This is just for fun. We'll have to answer a question like this on the next page. Hey Daisy, can I pick on you for a sec? Still out there, Daisy? There's Daisy. Jose, you out there? She has her microphone on.
Yeah.
Oh, okay. So I'm going to pick on you for a sec, okay, Jose?
Okay.
All right. So when you look at those two numbers, right, the 1,000 for China and the 2,600 for the U.S., like what jumps out at you first about those two numbers? Like if you were just going to make a comparison without whipping out a calculator, what would you say?
Probably the difference between the water usage that we use compared to the one in China.
Okay, so what jumps out at you about the difference?
Probably the number, the difference.
Yeah.
Probably the double the amount we use. Yeah.
Yeah. So it looks like U.S. uses about twice as much. Okay.
Yeah.
So,
twice as much as water.
Okay. So whenever I'm doing it, like I need to compare some numbers, I just kind of go with my gut feeling. I'm like, whoa, U.S. uses twice as much. How would I calculate that number, twice as much? What would I do for math? With these two numbers right here, what would I type into a calculator to get about? Because it looks like about double, right?
Yeah.
I wouldn't subtract. I would divide. Yeah. What order would I divide in? Bigger number by the smaller number. Yeah. So you can do it either way. It'll just tell you two different things. So I'm going to do it both ways and see what it tells me. So, and I'm just going to round these numbers a little bit. So I'm going to take 2,600 divided by 1,000, and I get about 2.6. So this says and the average person in the U.S. uses like 2.5 times more water than the average person in China each year, is what that tells me.
They're all compact, would be one reason none of them have a yard.
Really, you've been to China?
I don't know.
I don't know. Yeah, when I think of China, I think there's some big cities, but mostly I think about China is a lot of farmland and open spaces is what I think about. But I haven't been there either, so I don't know. There's not much available. They use way less too. Yeah, so I think one reason for us, do you remember the chart I showed earlier of where my biggest water usage comes from? Does it come from the water I use in my house? Does it come from the water I use in my yard? No, it comes from all the other shit I do, right? Like, do we have a lot of cheap plastic crap? I do. Sorry, I got to admit that. Do you know how much water it takes to make cheap plastic crap?
Doesn't it come from a lot of farming?
Farming too, right? Yeah, it takes a lot of money to grow grain. Sorry, a lot of water to grow grain, grow corn. And if you eat a lot of meat, it takes a ton of money to feed and water the animals. So the more meat you eat, I mean, I mostly eat vegetarian. I cook with meat once in a while. My diet usage is around 790. If I said I eat meat every day, that would jump to like, 2,000. Crazy. Yeah. Yeah.
Like natural springs.
Yeah.
Is that the same as that?
That counts. Yeah, it's still water usage. Yeah, so it's in there. Yeah. So the bottom line is when we think about water usage, it's not just the water we pull from pipes, but it's the water we get from any aquifer, any river, any lake. It's still water in this water cycle that we have. We talk about fossil fuel shortages, that someday we're going to run out of gas and oil. Gas and oil is nice. I like driving around. How about you guys? Yeah, I like my car. But is water more important than driving? How long can you live without water? 3 days? Yeah, so if you don't have good water, you're dead, right? If you don't have gas, well, you're going to walk more. So water is going to be a bigger deal as we get more and more people, and we keep getting more people. Anyway, I'm a little off track there. So I was going to do a calculation, right? All right, so 2.6. If I switch those numbers, what do I get instead? 1,000 divided by 2,600. What does that tell me? How would I describe that? So my mom wants to know, what the heck does that number mean, Gary? What did I tell my mom? Comparing China to US. What would that be as a percentage, roughly? About 38, 40%? Okay, so now put that in a sentence comparing China to the US. China, it's not 39% less. They use 39% of the water we use. They actually, if you subtract that from 100%, so if I do, let's just call it 40%. If I subtract that from 100%, I get what? 60%. So people in China actually use 60% less water than I do, which is a slightly different comparison. And I have to do a subtraction and a division to get that one. We'll talk more about those changes later. But just straight division, this tells me that people in China use about, rounding, 40% of the water we use. So if somebody here said, hey, I use 100 gallons of water a day, then a person in China would use 40 gallons of water a day, doing, your average person there, is what that tells me. Okay. All right, my turn to shut up, and your turn to take a look at the next page and start writing some sentences. By the way, I'm pretty sure we just did question 10. Take a look at that one. And then as you look at these, Jose and Daisy, if you have a question, either, there we go. Let's see. Yes, I got your message there, Daisy. If you guys have any questions, either chat me a message or voice in if you're stuck on something. Let's see. In the fourth column in the table, we want to put the amount. Yeah, we already did that one. Yeah, so they're calling the fourth column. Where we go? First column is country, second column is people, third column is total water, fourth column is water per person. So we got that. So we did 8. I highly recommend finding a partner to check answers with, a neighbor. So you've got about 5 or 6 more questions to answer. Should be pretty good. 15 minutes or so. If you need help or a tip from me, just holler. Yeah. Yeah. Oh yeah, let me go over that. All right. So Robert had a question about ratios, percents, and fractions. So I'm just going to pick on that the China compared to the U.S. example. So when I compared, switch colors, China to the U.S., it came out roughly to let's call it 0.40. Okay, if I round to the first decimal place, the nearest tenth, I'm going to put a 0 in the hundredths place. When I read that as slang, it's 0.4 or 0.40. The proper way to read it is to say that's the 10th spot, that's the 100th spot. So this is really 40 hundredths, right? Hundredths. Get some hundredths today. How's that? Anyway, which says that's really a fraction, right? 40 over 100. So I could reduce that by dividing out a 10 top and bottom. So I could call it 4/10. Can I reduce it further? They're both even, right? So I could take 2 into the top, 2 into the bottom. So 2/5 would be another way to write it, and I can't really take it much simpler. So here it is as a fraction. Up here it's a decimal, right? When I want to change a decimal or a fraction to a percent, the trick is to multiply by 1. And 1 is actually 100%. Right? What's the percent symbol mean? Divide by 100. What was that? Divide by 100, yeah. So really what this means is 100 divided by 100, which is really what? 1. So anytime you have a regular number like a fraction or a decimal, if you just take that number and you multiply it by 100%, then you leave the percent symbol hanging out and you just clean up that part. What's 100 times 0.40? 40, so that gives me 40%. And some of us are just used to looking at these things and saying, yeah, I know that's 40%, right? 40 out of 100. But sometimes it's worth it to do that calculation. Okay. So let me just give you another example. I went to the bank recently to make a savings account, and in savings account, they pay you interest for keeping money in there. Do savings accounts pay a lot of interest? They pay almost nothing. So what the bank said is they pay 0.5%. Less than 1%, right? Okay. So isn't a half the same thing as 0.5? So that's really 0.5%. Okay. If I need to do a calculation, don't I need to change that to a regular decimal? It's not currently a regular decimal because that percent symbol is sitting there. What's percent mean again? Divide by 100. So that's really 0.5 divided by 100. And dividing by 100 shifts the decimal point how many places to the left? 2. So I'm going to have a 0.005. Okay, so just warming up to that, 0.5% would be the same as tens, hundreds, 5,000ths. So half a cent, right, for every dollar I put in the bank. Not much. Okay, so just a little review of fractions, decimals, and percents. We'll do more throughout the next couple of weeks. All right, back to work.
So let's give them
Question 8 is the numbers in this column right here that we calculated. Yeah, so you can just say it's in the chart. And I think for a good label for that column, you could just say it's water per person per year, but what's the water measured in? Yeah, you got to put cubic meters in there too. So it should be cubic meters of water per person per year, or per year per person, either way for that part. So you want to make sure you have a good title so you know what it looks at like later. Let's see, how do we find the survey? Oops, I lost Jose. Waterprint, yeah, Canvas 1.4. Thank you, Daisy, for pointing Jose in the right direction. All right, you rock, Daisy. Oh, Jose's back. Did you find the water footprint calculator, Jose? So if you follow the National Geographic link in lesson 1.4, it takes you to the National Geographic page. And then read through some of these facts about water usage. And at the bottom of those facts is the link to calculate your water footprint. And it'll ask you a bunch of questions about how big your house is, how many people are in there, things like that. And we found one person had a hard time getting it to run in Internet Explorer, so they tried a different browser like Firefox or Chrome. Jose came and went. Hopefully he heard that. I just noticed something interesting, y'all. I was looking at China to US and US to China. So we already figured out that China, US uses about 2.6 times more water, or China uses about 40% of what we use. But if you look at the populations, they're kind of switched. We use more than twice as much water, but they have more than 4 times as many people, which is kind of interesting.
So they use the 2.59 more than we do.
China uses 2.6 times of what we use.
So, see that you are.
Yeah, you could do it either way. I think because they said China first and then world, I would flip those with China on the top. Because this says that there's, let's see, whole world, there's like 5 times as many as in China. So you have to give up that. So usually when somebody asks me to do a comparison, the thing they said first is on the top.
So how did you guys look at the conversation?
This one right here. So I was trying to compare China, let's see, China to the US. So I took China, so this is another point. When we write a ratio is a kind of fraction, this to that. So the first thing is the top number and the second one is the bottom number. So I took China divided by the US.
Okay.
So it's about 1,000 divided by 2,600. That's where I got that number right there. Yeah, so the order we write this to that is the order we divide.
That's in, yeah.
The numbers here are in cubic meters. The National Geographic survey is in gallons per day. This is in cubic meters per year. So, well done. Nice. Sure. All right, so if you finish it up today, feel free to give it to me. If you want to take it home and work on it a bit more, give it to me next class, that's fine too. Just show some work, yeah. Or just say, hey, it's on my spreadsheet. You can just send your spreadsheet.